Okay, in this video we're going to look specifically at the problems that ask determine if a function is linear, exponential, or neither. So how do we decide that? Well, first we have to kind of figure out how a linear function behaves. We've looked at the graphing for it a little bit and for equations. But let's look at one that's in the form f of x equals c times a to the x. Now, like I said before, a lot of the functions that we look at don't have this c out front, but let's see what happens when it does. So let's look at this with numbers because it's easier to see that way. Let's say we have 5 times 2 to the x. Sorry about that. If you hear there's a thunderstorm in the background. Sorry about that. So let's look at this for some different values. So let's say we have f of 0. So that means we're going to plug in 0. So we've got 5 times 2 to the 0, or just 5 times 1, which is 5. All right, and if we look at f of 1 is 5 times 2 to the 1, so that's 5 times 2 is 10. And if we look at f of 2, we've got 5 times 2 squared. That's 5 times 4 is 20. F of 3, 5 times 2 cubed. 5 times 8 is 40. Now we could keep going with this, but you probably have enough here to see the pattern. So if you look, we're putting in our x values are going up by 1, 0, 1, 2, 3. Okay, so our x values go up by 1. All right, and what is happening to our y values? We go 5, 10, 20, 40. Our y values are doubling. Okay, so why are our y values doubling? Well, if you look in here, you might see it, or maybe right here. Each time the exponent goes up by 1, we get another factor of 2. So each time we go up by a 2, and that gives us our doubling. So this change right here, the fact that it's doubling, comes from this right here. Every time we increase x, our base increases by that much. Okay, so our general rule for exponential functions, looking at this pattern, we say that f of x plus 1 over f of x is equal to a. And this notation might seem a little bit weird, but let's look at what it's talking about. It's saying if you look at a y value, and then you put that over the y value that came before it, or if you think of this as the y value, and then this is the y value that increases the x value by 1. So y over the y that came before it, that should be equal to a, where of course a is our base. And we can see that over here. If we took this y, let me change colors here. If we did y over the y that came before it, we get 2. And this one we do y over the y that came before it, and we get 2. And then this one, y over the y that came before, and again, we get 2. And we can see that here because the numbers are pretty easy to manage, but that's going to happen every time. And just like we said, that 2 comes from this base. So let's see if we can use this with actual data. Okay, so if we're given data, how do we decide if it's linear, exponential, or neither? Well, let's remember back to linear. We did this before for linear. And remember, if we want to know if data points are in a line, we look at the slope. So for linear, we look at change in y over change in x, and we're looking for that slope to be changing constant, so they all have to match. And then we just said for exponential, we're going to look at f of x plus 1 over f of x, and we need that to be constant. That number's got to match. So remember, if linear, if it's true, then it's going to be the slope, and if exponential is true, it's going to be the base. So when we look at data, first of all, in order to test for exponential, they've got to be going up by 1, and they are here. So this one, we could test for linear exponential. Let's look at the y values and see if we can kind of figure out what's going on here. Does this look like exponential? Does it look like it's doubling or tripling or anything like that? No, it doesn't. There's, we're not seeing that kind of doubling pattern. So let's test for linear first. So we're going to do change in y over change in x and see if the slope matches. So remember to do that. We're going to do y minus y. So we've got 5 minus 2 over 0 minus negative 1. Minus a negative is the same as adding a positive, and so we are going to get 3 over 1, which is equal to 3. Okay, now we've got to test the next one. A little cramped here. We're going to do 8 minus 5 over 1 minus 0, and again we get 3 over 1 is 3. And then testing the last one, we're going to do 11 minus 8 over 2 minus 1, and again we get 3 over 1 is equal to 3. So this is what we were looking for linear last time, if you remember, and they all match, so yes, it's linear. Sorry about that thunder. And we know that the slope is equal to 3. So remember, to make our linear function, we would use y equals mx plus b. We know that 3 is our slope. And we would use any one of these points to find our b. Now remember, on these, maybe you could actually see the b, which is the y-intercept right there. But if not, you could go ahead and plug in a point and figure out what b was. So let's say we're going to plug this point in. We've got 5 is equal to 3 times 0 plus b. 3 times 0 is just 0. And we get, my pen won't go that low. We get 5 is equal to b. So now we can go back to our equation and plug in m and b, and we get 3x plus 5 is the equation of our line. Okay, so that should look familiar to you from way back in section 4.1. Now let's see if we can do another one just like this and test for exponential. Okay, so let's try one more of these. Here's a new set of data points, and again we want to decide linear, exponential, or neither. You can test for linear first or exponential first. It really doesn't matter. You can just kind of go with your gut on what you want to try. When you see these fractions here and think maybe not linear, you know, that might be a good guess. If you did test for linear, they wouldn't match, and you would say, okay, not linear, and you need to move on to exponential. So let's just go ahead and test for exponential, and that's where we're going to do this f of x plus 1 over f of x thing. And remember, that means y over the y that came before it. So this is the one that's after, or this is the one that's before. So we're going to do, the x's need to go up by 1, which they do, and we're going to do y over y. So we're going to do 1/2 over 1/8. So y over the y that came before it. Now you can put this, since they're fractions, you can put these in your calculator, and if you do, remember your parentheses. Or you can just remember that dividing fractions is the same as multiplying by the reciprocal. We get 8 over 2, which is 4. Okay, moving on to the next one. Y over the y that came before it, we've got 2 over 1/2. Again, if you put this in your calculator, do not forget the parentheses. Or you can change it to multiplying by the reciprocal, and we get 4 again, so this looks promising. And then the last one, we do y over the y that came before it, 8 over 2, and of course that's also equal to 4. So we tested for exponential, and they all matched, and so we're in good shape. We know that this is exponential. Okay, so where do we go from here? Well, it's very similar to the linear case, okay, except this is exponential. So we are going to remember that exponential means that you found the base. So these, sorry about that, these all match, and so we know that a is equal to 4, and we put them into our exponential model. So this is our linear model. We use that for lines. For exponential, we use our exponential model. Oops. And that's this one, f of x equals c times a to the x. Okay, so similar process to the linear, but this time we're doing exponential. So we knew that our function is f of x equals c times 4 to the x. Okay, we know that much. We know that a is 4. Now we've got to figure out what c is. How do we find c? Well, we do it the same way that we did over here. We plug in an x and a y. So we plug in an x and a y, or an f of x. And you can pick anything out of this. Sorry about that dinging, guys. You can pick anything out of this, this chart. So 0 and 1/2 seems like the easiest thing to do, because 0 is easy to plug in. So 1/2 is our y. C is what we're looking for, and we're plugging in 0 for x. Now remember, 4 to the 0 is just 1. Anything to the 0 is 1. So this is the same as 1/2 equals c. And now we know what our equation is. We put c back in here, and our function is going to be 1/2 times 4 to the x. Okay, and we've got our exponential equation. And you can come back up here and check, like if you plug in 1, does this work? If we plug in 1, we've got 1/2 times 4. And that is the same as 2, so we know that our function works.